So we have about 86 people signed up now, which is roughly the same number of people who attended the algorithms workshop, and I'm sure that's just a coincidence. So let's get started. Can everyone see my slides?
It's good.
Good, thank you. Okay, so welcome to this breakout session on the Rubin Algorithms Workshop Follow-up. This session is designed to be a question and answer session in follow-up to the Rubin Algorithms Workshop that was held in March earlier this year. Oops. I'll just start with a few friendly reminders that you will hear in every session. A reminder to people that when you signed up for the PCW, you agreed to abide by the Code of Conduct. Steve has already presented this in detail in his plenary just now, so I won't go through every detail again. But just to note, there are the 3 key points about adhering to the principles of kindness, trust, respect, diversity, and inclusion, about not behaving in a discriminatory manner. This sort of behavior will not be tolerated. And if you do witness any form of harassment or bullying, to please report this following the instructions in the Code of Conduct. A few other reminders: all the talks at this workshop will be recorded, including this one. Recording has already started. If you do not wish to be recorded, you are welcome to turn off your camera. The videos will be posted the next working day on the workshop webpage. Please feel free to use emojis, give Slack questions a thumbs up, and please show your appreciation for questions and speakers in the Slack channel. So just a quick recap to set the context before we start. In March this year, we held a virtual format workshop on the topic of image processing algorithms for the LSST. And the idea of this workshop was to present the algorithmic challenges faced by the LSST project and to solicit feedback and ideas as to how the Rubin data products can best meet the scientific needs of the community. We did originally plan to hold an in-person workshop with a lot of time planned for unstructured discussion. Unfortunately, due to the uncertainty around COVID-19, we had to cancel that in-person workshop, and we converted it to a virtual workshop. All the talks from this workshop were recorded, and they're available from the Rubin Algorithms Workshop website. I would encourage you to listen to these talks if you have not already. They present a lot of material on the Rubin algorithms and the science pipelines, and I think they make a very excellent introduction to people who don't know a lot about the science pipelines, and they are also, I think, a very good resource for more expert people to get an idea of what we're planning to do with the Rubin algorithms and science pipelines. And so in follow-up to that session, and given that we were unable to include the unstructured discussion time in the virtual format workshop that we held in March, we decided to hold a Q&A session at the PCW this year in order to give the community a chance to ask questions, discuss with the team in follow-up to that workshop, and also to open this session to anyone who wanted to attend, so people who might have listened to the recordings after the workshop to also come and ask questions. We solicited questions in advance of this workshop, and we will start by going through the questions we received in advance, and then we will open it up for more open discussion. Sorry. Okay, so just a note on the session format. We will use essentially the same model that we used for the virtual algorithms workshop. We will use the Slack channel to discuss topics raised, to chat with other participants, and to ask questions. My co-hosts, John and Colin, will be monitoring this Slack channel, so we will queue the questions up in this talk if people would like to ask them and discuss them, rather than just talking on Slack. We will use the Zoom raise hand feature if you would like to ask a question. Zoom chat, however, will not be monitored by the moderators. We would like to keep all discussion within the Slack channel, or questions within the Slack channel. It's easier for our moderators to track what's happening, and it also provides us with a history that we can consult later. So just a quick note on the agenda and some introductions. The chairs of this session are myself and Colin Slater. We have several people presenting. Yusra, Jim, Robert, and myself will go through the questions that have been submitted to us in advance. John Swinbank will be the scribe who will take notes from this session, and Colin Slater and John Swinbank will also be the chat moderators. And so just to re-emphasize, our session today is questions and answers. We haven't prepared anything other than answers to the advanced questions we received from you. We are prioritizing, we reorganize these questions that we received into two different groups. There are those that pertain directly to the topic of the algorithms workshop, which was image processing algorithms, and we will address those questions first. We then received other questions which are related to the Rubin Science pipelines, but which were not directly related to the topic of the algorithms workshop itself. We will then go into those questions, and we will then open the floor for open discussion. As we go through the questions, we will stop after every question to allow people to ask questions on the question that is answered, and perhaps engage in more open discussion if there's a need to. Oops. And I'd just like to start by saying that the work presented at the Algorithms Workshop and the work in this follow-up Q&A session represents work done by the whole Rubin Data Management Science Pipelines team, who you can see here. And not only are they hard at work building the Rubin Science pipelines, but they're also very enthusiastic skiers and snowshoers, as you can see, and connoisseurs of fine food and drink. Okay, so we'll start this session with questions received on the topic of Rubin image processing algorithms. The first question will be addressed by Robert Lupton. Robert, I hand it over to you.
Oh, okay. So, hello, everybody. This
And Robert's frozen.
was the question of discovery of asymmetric. Sorry, can you hear me?
Yes, you just froze for a minute, that's all.
Yeah, my internet's misbehaving. Was the discovery of
Maybe, Robert, if you turn your video off, it's unfortunate.
asymmetric drift in the DC1 or in the stars when we're doing the analysis. So we were asked, would we like to rerun the DC? And the answer is no, but not because we haven't fixed that problem. We have now successfully the positions at epoch, and we are working.
Robert, you're really breaking up.
On the code to calculate the proper motion is fainter than the reference catalogs down to the single frame limit. But we don't think it's different since those days. We might ask to run some DC2 simulations with proper motion parallaxes turned on. That would be a nice cross-check. We've also got 5 years of hypersupreme cam data.
Robert, your internet is too bad to make this workable.
Which have all the same and okay.
There's a suggestion that Jim this question.
I can try morning. So do you want me to start again, Leanne, or what?
Please, yes. I don't think that we got any of that, unfortunately.
Can you try tethering a cell phone or some other more stable internet?
No, it doesn't work. I have no internet in my house. I have no cell phone coverage here. It's not London. Okay, so there was a problem that was discovered in DC1, which was that the stars moved, but DM didn't know about it. Okay, so we rediscovered the asymmetric drift. Since then, we've put both interpolating the positions of reference stars to epoch, proper motions and parallaxes into the code, and are experimenting, implementing at this point at an experimental level with predicting the parallaxes and proper motions of all the faint stars which are detected in the single frame processing. So that's down to 24-ish or something like that. We don't think that rerunning DC1 would be useful, partly because it didn't use a real reference catalog. It used a Mario Jorich reference catalog, which you would have to fake up in the right format. And also because if we wanted to do that, we would rerun a little bit of DC2 with motions and parallaxes turned on to confirm the code works. But in fact, our initial testing is being done on the hypersupreme cam data, where we have at least 5 years of data in Cosmos. So we feel that that's the easiest place to start checking that we're doing sensible things. But DC2 is a possibility.
Do we have any follow-up questions on this topic for Robert? Okay, doesn't look like it. So let's move on to the next question. Oops. Okay, the next question is on sky subtraction. I'll hand it over to Yusra to respond to this.
Oh, thank you, Leanne. You'll remember that the context was that background is in the eye of the science use case. One person's intercluster light is another person's background. So in our experience of the HSC data releases, we found that changing the backgrounds subtraction scheme between data releases made one data release better for low surface brightness science and another data release better for weak lensing science. We believe that it is possible to provide background models that are that enable almost all science use cases. We are planning on implementing our plan for background subtraction over the next couple of years. It's going to be in active development. If your science is sensitive to background subtraction and you have experience validating background estimation before you do your analysis, we want your metrics. And this will allow us to make changes to the background estimation scheme and try more hybrid approaches with the confidence that your metric and science use case won't be left behind. So there was a question on exactly how to do that. So reach out to me on community. Your contributions can fall anywhere on a sliding scale between just an idea for a plot or go as far as joining Stat Club and writing a notebook to provide an analysis on our precursor data sets. But what would be most useful to us is code that produces a plot and some kind of number, a performance metric for the pipeline. Should that number be higher or lower? What is a reasonable number and why do you think that? And bonus points for answering questions like how much area you need for that to make sense. Thank you.
Thank you, Yusra, for that answer. Do we have any follow-up questions? Colin, is there anything in the Slack channel?
I don't see any.
Okay, let's move on to the next question then.
Alrighty, so this is the first of 3 slides on co-addition. So there was the talk at the workshop was about approaches to co-addition, and I won't be able to recap the whole thing here, so I'm going to mostly focus on the questions. I'm certainly happy to provide some more context in terms of follow-up questions. So the question here is that, this talk brought up lots of interesting and novel ideas about cell-based and object-based coads. But the big question was whether these novel coads were being planned for DR1 or whether they're a more longer-term project. And I think we will definitely do something different in our handling of edges by DR1. And I think that's going to have to involve some kind of rejection of single epoch cells, whether that's per object or predefined, that have discontinuities or missing pixels. We can't continue to just let the discontinuities or the missing pixels land wherever they will on the coads, because I think even at DR1 scale, that's going to be problematic. That doing that at all creates a different set of problems for the algorithms that run on the coads. Right now, we can sort of assume that for most objects that we can get a decent continuous PSF. I think in order to handle those coads well, we need to solve different problems about how to process them. And one way to do that involves using the Kaiser coads that I also presented in this talk. That's not a change to how we sort of structure the way images contribute to a coad, but it's a change to how we would combine the images. And that's made possible by making cell-based coads, but it's not necessary for making cell-based coads, but it also solves some problems. So this is a risky idea that I think we need to demonstrate at sort of a basic level that will work on the kind of data we have. But if it can make it work, then it will solve or help us to solve a lot of those new problems that making cell-based coads create. So the basic idea is, yes, we're definitely going to do something different by DR1 that may or may not include Kaiser coads. Next slide, please. So this takes me to the next question, which is when will decisions be taken about what baseline co-addition process will be adopted and implemented? So I think there is a decision point for DR1 about Kaiser coads. And that really depends on that small scale testing work. That testing work, I think, is something I started a while ago. It's been stalled recently while the DRP team work is focusing on other things. But I'm hoping that once we pick that back up, we'll get an answer pretty quickly on whether Kaiser coads are worth pursuing. And then that will be a decision in the not too distant future. But after that, I think it's hard to frame this as a single decision point or even a number of decision points. It's just going to be a process of iterative improvement. We're already, I think, in close communication with the desk team that's caring about this the most, doing shear measurement and building coads of using some of our code and some of their code for shear measurement. I think we're going to continue to work closely with them, and I think if you want to be involved in that, it makes more sense to contact us rather than expect for the project to sort of push big announcements about where co-addition is going at some point in the future. It's going to be small scale, continuous work. I think it's unlikely that we'll make substantive changes to this by the beginning of the data previews, but I think we'll have some more answers on the Kaiser coad question around that time. Next slide. All right, so then the last question is, how should interested scientists best interact with DM on providing validation tests and science-driven metrics, and on what timescale, for coads in particular? So I would encourage you, if you think you care about coads, think instead about what you think coads might do to the objects you care about in the catalog measurements, and try to make metrics that are defined on those measurements. That gives us more flexibility about what we do with coads, and we can, for most people, I'm hoping, think about coads as an implementation detail. On the other hand, if you're already developing your own image processing code, as we know that desk shear measurement group is, and especially if you have stringent PSF accuracy requirements, as certainly weak lensing does, then I think we'd like to work more closely with you and make sure we have that kind of relationship where nothing we do will upset your plans. And I think, again, that desk group of pipeline scientists working on shear measurement is sort of the model for how we would interact with others on that. I'm not certain that there are any others who care at this level of detail, but I'd certainly be interested to know if there are. That's it. Any questions on this topic?
Michael, do you want to ask your question live, or do you want to leave the Slack question for Slack?
So when you only have 10 or 20 images, the impact of a particular edge or mask or partial completion on an image on a coad is significant, but so is the loss in signal to noise. Whereas when I have 200 images, both are much smaller. Is there a scaling to understand of impact on having a pure PSF versus depth?
I think the other variable that's missing there is the size of the cells. And that gets into this question of how we can, and whether we can process coads that have piecewise continuous PSFs, but possibly many, many discontinuities on a well-defined grid. And I'm hoping to basically make your question go away by making the cells sufficiently small that you barely lose anything more in signal or noise every time you reject one of these little cells. But that really depends on us being able to demonstrate that, and that's one of the things I'd like to be able to do with Kaiser coads. So there's certainly there's a potential trade-off there, but I would like to avoid worrying too much about it, because we'll have to do some detailed work on what the trade-offs are, and including what you lose for adding images with different PSFs and so on. And we can just sidestep a lot of that if we can do this with small cells Kaiser coads, and that's my hope.
And apologies that I actually didn't ask this in the original questions, but how does this relate to template generation for DIA? I mean, naively, it seems to be going in a different direction than trying to get a consistent PSF across an image.
Yeah, I think whether we adopt DIA to use these as templates is sort of a separate question that I think is worth asking once we've got them up for deep processing. I don't think anything we do in planning them for deep processing will make them impossible to use for DIA, but I don't think the DIA work can wait for us to get these coads up and running before they try to optimize their templates. So it may be a longer term question for DIA.
Thanks.
Owen, do we have any more questions?
I'm just going to, Brent Robertson has a question that I think fits here well. you want to ask that live?
Yeah, I was just wondering where the best place to look for details on the co-addition methods. You know, where should we look?
I think the talk from the Algorithms Workshop is probably the most complete one. I'm aware that it's missing some mathematical details, but I think I put links to papers that sort of fill in that missing information there. We don't have a complete write-up. I've got a rather old tech note that you can probably still find on the Rubin documentation sites. But the Algorithms Workshop is certainly what I would recommend as the latest summary right now, and we don't have anything more detailed than that.
Jim, how much discussion of chi-squared, not Kaiser, coads do you have in
Almost none.
that talk?
Okay. Colin, I think that's all the questions we have on this topic.
Yes.
Okay, back to Yusra now, a more general question on algorithms.
Okay, so this question, for what algorithmic areas would we receive science-driven metrics from the community, and what time scale? So most of my answer for the background subtraction holds for this. It is best to post on community and iterate a little bit on ideas before you put too much work into this. And the reason for that is the same metrics can be used for testing both image quality and pipelines performance. And for example, photometric repeatability metrics could test both. So in order to test image quality, you hold your pipeline fixed and you change your data. In order to test pipeline performance, you hold your data fixed, your images fixed, and you change the pipeline. So in order to disentangle this, it does take a little bit of work in the beginning when you're running a new metric on new data. So for example, if you've designed one-off simulations to test something in particular, that might not be as robust to LSST-like data without a lot of work going in ahead of time. So yeah, look at the different levels of contribution for the sky subtraction contributions and reach out to one of us on community.
Okay, Colin, do we have any follow-up questions to that?
I think we're good.
Okay. Okay, so that concludes the questions that we received in advance from the community, which were directly related to the topic of image processing algorithms, the topic of the Algorithms Workshop. We received several other questions on other aspects of the Rubin Science pipelines, which we're also happy to address, and we will move on to those now. Okay, so we received a few questions on PhotoZ. Eric Goweiser from Desk asks, would it be possible for a community photometric redshift algorithm that also calculates star galaxy formation rates, stellar masses, dust reddening, and stellar ages to be adopted by DM, and to have those results appear in the data release catalogs? So yes, we think that it is certainly possible for DM to adopt a photometric redshift algorithm that does this, and that yields galaxy properties in addition to PhotoZ. And that we could certainly have these results appear in the data release object catalogs. Just a note here though, that the primary goal is for us to produce robust photometric redshifts. Galaxy properties is a plus. It's not a core requirement, but I think that if it doesn't pose any problems, and that if the algorithm is widely blessed by the community, that we don't see any problems in being able to do this. And as just a general note going forwards, the project will be working with the community to choose a PhotoZ algorithm for inclusion in the Rubin Science pipelines. Any follow-up on that, Colin? Eric, I hope that addresses your question satisfactorily.
Great, thank you.
Okay, we had a few other questions on PhotoZ as well. from Desk. What will be the basic photo Z in DR1? So the answer to this right now is that it has not yet been decided. We haven't made that choice. The project is going to work with the community to put in place a process to get input from the community and to converge on a choice of algorithm for photo Z in DR1 that is agreed by both the community and the project. And there will be details on this process and how we hope to achieve this coming soon within the next 6 months. Just a note as well is that we expect to revisit the choice of photo Z algorithm as part of every data release. So it's not something that we have to get right now. You don't have to say, well, this is the photo Z algorithm we want, and then that's going to cover the full 10-year survey. This is something that will be living, that will be ongoing, and we can reflect upon with every data release. Colin, any follow-up? I don't see anything.
I don't see any questions.
Cool. So a second part of this question on photo Z is there was a note that there have been several presentations and discussions at previous meetings on the topic of photo Z and the LSST data products. Melissa Graham has been key in leading these discussions, and I've put a link here to the breakout session that we had at last year's PCW, chaired by Melissa, on the topic of photo Z in the LSST data products. The question here is, what are the next steps that the community should take? How should interested scientists best interact with DM on providing algorithms, validation tests, and science-driven metrics, and on what timescale? So as I've just outlined, the DM science team, the DM science team are working on a tech note which will guide this process of selecting a photo Z algorithm. The tech note's entitled Options for Photometric Redshifts in the LSST Data Release Object Catalog. This is a work that we currently have in progress at the moment, and we expect to circulate a first draft of this to the science collaborations for feedback by the end of 2020. This goes hand in hand with us starting up the process, defining the process and starting up the process by which we will work with the community to choose a photo Z algorithm. We would like to encourage discussion of all aspects of photo Z in the LSST data products on community.lsst.org. We're certainly very interested to hear at any time what people are thinking and what they have to say. And I've also referenced here Yusra's excellent response on providing validation tests and science-driven metrics for sky subtraction. This process also applies to photo Z. Contributions may be offered at different levels of investment as outlined by Yusra. Colin, do we have any follow-up to that?
I think Michael Strauss has a question about photo Z.
So I was just, it's one thing to have a photo Z algorithm. The next thing is to make it battle tested, ready to go, fully working code within the Rubin framework. I was wondering where the responsibility for getting it into that step would be in practice.
Okay, so I would see this as a joint responsibility with the community and the project to work together on making this battle tested. But I'd also like to invite Yusra and Jim as the pipelines developers to weigh in on this.
I think you've hit the nail on the head on terms of what makes this difficult as something that we would take from the community. And right. I think it's clear that the process here needs to be able to, which we haven't come up with yet, but we're working on, needs to be able to define a way that we can make sure that whatever we get is robust, either because whoever delivers it is responsible for running it and making sure it's robust, or we give them enough time to work with us to make it robust in the course of a data release or something along those lines. I think this is indeed a hard problem.
And I think Sir Hood Moore has a question about photo Zs.
Yeah, so I wanted to ask if there's a possibility to include more than one photo Z algorithms. Typically, it's good to work out systematics, for example, dependencies of results on different photo Z codes. Or is there always going to be one photo Z algorithm that will be put in the database?
So I would answer that by saying we're not restricted to one. We are certainly open to thinking about including more than one, but it has to fit within our compute and storage budget. So we would have to evaluate what the algorithm is and what is required to run more than one algorithm. Again, I'll invite Jim and Yusra to weigh in here as well.
Yeah, and I think to a certain extent, I mean, we already have ways people can take, say, their own PhotoZ algorithm results that they've produced and federate them with our catalogs and make them available to others. Those have been planned as part of the Science Pipeline platform for a while. And I think what differentiates this PhotoZ, this special PhotoZ we're talking about from those, is perhaps timing in terms of when it comes out relative to a data release, and just the fact that we're trying to guarantee that there will be at least one, but there's nothing preventing anyone else from making a federated catalog. We may also be able to support one in terms of whatever benefits that special one gets, but there's certainly nothing prevented, new PhotoZ algorithms arriving as value-added catalogs from the community.
So just one quick follow-up as well, and this is about whether the accounting of the storage capacity and so on, that includes the PDFs of the PhotoZs, or only just like a point estimate?
There is certainly some accounting for the PDFs. I don't believe there's been any convergence on exactly how you would compress those, but I believe the storage was fairly conservative. So if with any kind of compression, we shouldn't have any storage problems.
Conservative in the sense we gave you lots of space, not small amounts of space.
Yeah, the reason for people being conservative about this is because it's a lot of space allocated to the PhotoZ algorithm. So if someone said, hey, can you just compute like these 3 numbers too? That's a different discussion than can you compute another set of 200 number PDFs?
Yeah, that's exactly why I was asking. Thanks.
Okay, so I think that's it, Colin, for the questions on this.
I think that's the PhotoZ question. So we're getting a few for the general topic, but let's keep kind of going through the slides, I think.
Okay, so one final part to the PhotoZ question was how should desk share and publish its set of PhotoZs that it derives? In fact, Jim has just touched on this. The Rubin data management system will provide a means for federating data release catalogs with user-generated catalogs. So as Jim said, people are free to run their own algorithms, generate their own PhotoZ catalogs, and there will be a facility provided that will enable you to federate these with the data release data catalogs to enable a joint analysis, and also to share these with other users on the Rubin Science platform. Okay, I don't see any follow-up to that. Okay, let's move on to timelines. Back to Jim.
Okay, so these are a number of questions on when we plan to deliver things that we mentioned in the workshop. It's hard for us to be super specific about these, but these are, I think, will give you some idea, and probably about as much as idea as we have in terms of being confident about when these things will land, because they're all, work that's somewhat uncertain and researchy in nature. So first, PIF. PIF is a PSF modeling code that's been developed for devs and by some members of Desk. We're already working on integrating this into the pipelines. We actually have it running as part of the pipelines, although we don't have it yet connected up to be able to feed the later stages of our pipelines. We're looking at the quality of results. I think we can get this fully integrated and usable in the data preview era. I think whether it is better than what we have right now in all cases is not something I can guarantee, at least for the early data previews, but I think there's a good chance that it will be. That's talking about PIF and sort of its existing pixel basis mode. More advanced PIF topics or PSF modeling topics, I think, would be a subject for follow-up questions if you have them. The deblender. So I think we've made very good progress getting Scarlet running. It's now running sort of with comparable memory consumption and compute cost. It's not as fast, but it's ballpark now. As the older, we think worse deblender. But of course, as you run at more scale, you run into new kinds of problems you didn't have before. And I think we're going to have to spend some time squashing those bugs and those edge case issues with Scarlet. But I think we're not too far off from having this become the default deblender. And we just need to confirm that it is doing better while dealing with all those edge case problems. Galaxy photometry and shapes. There's a lot of different answers to this. I think first off, once we do get Scarlet running by default, it will provide good colors. It always has, and I think it's designed in such a way that it will provide good galaxy colors. The GOP approach that Conrad presented at the workshop, we have an implementation of that underway. There'll probably be some shortcuts that we'll have to make in the first version of that make it not quite as good as what Kids is running, but it should give us some idea of how it will perform. And of course, we'll work on that as needed to make it better and, up to the level of the Kids one. This is just about whether making it use our existing PSF matching code, which was originally developed for other purposes, and, the round peg, square holes kind of things. Model-based photometry is still mostly a research project. We've been continuing to make some progress on that, but I don't think we have anything to report right now. Ngmix, of course, is a code that can be used to do photometry as well. Right now, we're not planning to do any further Ngmix integration until the COAD stuff is further along. It's sort of interacting with many of the same people. And I think the big open questions about how that will work depend on making COADs more than they depend on just integrating Ngmix. So that's not planned right now just because it's a lower priority than something else that's related. And I've already talked about cell-based COADs. I think there's another slide on this same topic that we should probably go to before taking questions on these.
Yeah, although the next one's is less algorithms and more.
Okay, shall we do questions on this now then? If there are any. Let's see.
Chris Walter.
I was just asking for a clarification, so. I just don't know what gap implementation is, so I was thinking.
This is a Gaussian aperture photometry code that was developed, I know, well, possibly, I think prior to Kids by that same team when they were working on, I think CFHT lens was when it was first used, but it's a matched aperture approach in which you can essentially PSF match your apertures instead of PSF matching your images. And that makes it equivalent to, but much better in many respects than PSF matched photometry in the traditional sense.
So thanks. So this would replace like C model photometry, for example?
Well, so this, just like Scarlet, is something that would definitely replace C model photometry if you're interested in colors. It's not necessarily better, and probably not better, except that C model is so bad if you're interested in total fluxes.
So this would be in addition to the C model photometry.
Yeah, it would replace, I hope, most usage of the C model photometry, but not all.
Okay, thank you.
I think you're good to go to the next part of this.
Okay, so more timelines. In terms of data products, so we talked about, I think we talked about at the Algorithms Workshop, the various tables that are discussed in the DPDD. We do plan to make these available to science collaborations in the data previews with the format more or less as described in the DPDD. This is a separate topic that I think may be discussed more at other sessions this week, but we can certainly take some follow-up questions on that. Those of you interested in Gen 3 middleware, this is definitely not part of the Algorithms Workshop, but I can say quickly that we're in alpha stage already. Friendly and patient users who are willing to help debug problems and deal with frequent changes are welcome to dive in, and we have a few of those. I think we're aiming to push for the rest of DM to really start using our stuff in October 2020. Things will still be at a fairly rough stage at that point, but so is the Gen 2 middleware, and we think it'll hopefully be a good trade-off for everyone to start switching around that time. And that's sort of beta, but it's also will be the only game in town not too long after that. Workflow system development is part of Gen 3. The development's already active. And again, it'll be something we'll try to push on the rest of DM this October. Any other questions on this?
I don't see any others on the timelines question.
I do see one from Michael Woodvesi about actual dates. And right now I have a hard time saying absolute dates for things. I know I've personally been hit pretty hard by my productivity during the pandemic. And even without that, a lot of these things are research things that, I think if I put exact dates on when some of these things will arrive, the people who are experts in the audience about those things would say, how do you know when you're going to get that solved? And I think we would like to have dates. but I don't trust them myself very much on most of these topics. These are the topics we brought up because they are sort of research projects.
No, I understand. And I guess, well, I guess I should bug Will about this, but to represent a little bit, it is very challenging for the science collaborations to engage in these very questions that are algorithmic research questions without knowing what the timelines that the project is going to be pursuing and looking at these questions.
Yeah, and I think there's just a very difficult inconsistency there, because I think we in DM feel like we have to switch which things we work on somewhat agilely as new things become the tall pole. So it's hard to say that we're going to focus on this thing until it's done, when, you know, when we get this thing 50% done, something else is suddenly going to look like the really big looming problem instead.
I think that's going to have to lead to, I'm going to give this as an example. I'm not saying we're going to do this. You might imagine that Desk then might decide that risk management means we have to re-implement a lot of stuff because we don't know what's going to happen.
I'd like to think that our relationship with Desk is good enough that the best way to make progress on these things is to work more closely. I'm hard pressed to think of a subject in which we can't get this solved in time and someone else could, at least not without replacing large swaths of our pipeline with something that's running on a precursor substrate, like Desert Kits.
No, I agree. And I certainly don't hope that happens. I'm just trying to make a management point.
Yep.
Yeah, thanks, Michael. That's a good point, and we will follow up on it. Colin, do we have any other questions on this topic? I don't see any.
I don't think on the timelines. We're holding a few general questions if you're ready for those.
Okay, right. So that brings us to the end of the part of this session where we address the questions we received in advance from the community. I want to thank everyone in the community for sending us these questions, for listening to the talks, for thinking about what it was we presented, and for taking the time and effort to post follow-up questions for us. I really appreciate that. So we have about 15 minutes left in this session, and I will now open the floor for general discussion or additional questions on any aspects of image processing or the Rubin science pipelines.
I think it would be good to start with Meg Schwam. She's a good question here.
Hey, Meg.
Hi, I've just got a more general question. I sort of noticed that all of the submitted questions were from Desk. And I'm wondering if that's also a level of preparation in terms of science collaboration. So just in terms of a general sort of, where would people who are new, where would they should go to really dive in to get a good overview of all of the algorithms? And also, as things are changing, where to go to get information on that? It seems like there's a lot of information on the algorithms website. Is that the place to go? Where do we go for especially people that are new joining science collaborations in the next weeks, months? Where do they go to sort of ramp up to be able to engage with DM on the level that we saw in these other questions? Thanks.
Yes, thank you, Meg. I would say that the best place to go now for beginners and for new people to get an understanding of the algorithms is to the workshop website itself and to listen to the pre-recorded talks. One of the great outcomes of this workshop is that we now have a wonderful set of resources for people wanting to understand the algorithms, image processing, and science pipelines. So I would certainly start there. I invite other people in the pipelines team to respond to Meg's question.
I didn't have a good answer, Rob Lupton. I didn't have a good answer, but I would say that though Desk are a very squeaky wheel, and it appears that they're the only people who have any influence on the pipelines, people on project are very aware that there's the National Science Foundation science being done as well. And a lot of the pressure we get from the HSC collaboration, which many of us are involved in, is on the non-faint Tally Galaxy weak lensing science. So at least there are people who have your interests at heart. That doesn't tell you how to find out what we're doing, but it does perhaps address the apparent imbalance in favor of DOE.
One thing I would add is that it does depend on the nature of the algorithmic questions that people are interested in. But for people who are really new to the project, the data products definition document, which is LSC 163, isn't describing the guts of the algorithms, but it is giving the best overview of all the various data products that will be delivered and how they fit together. So that's where I would start, but understanding that that's not going to go into the depths of what you might be interested in.
There was also a point in the Slack chat that Eric's question was submitted on behalf of the Galaxies Science Collaboration. So it wasn't just Desk, it was Desk and Galaxies. But I do take your general point.
I think Keith, you want to make a point on that?
Yeah, so just one other resource that I think everyone should be aware of is that there is this community organized Stack Club, which has some level of support from data management scientists. So over the summer, there was a dedicated, I think, 8-week course, of which many of the instructors were members of the data management team or commissioning team on the project. And this was specifically designed to allow users to access the science platform and to practice developing notebooks and to use the stack. So there's both this course, but then the ongoing Stack Club, and there's a dedicated session on this later in the week.
Thank you.
A good entry point for new people.
That should be very interesting.
Okay, I think Will Clarkson has another topic to bring up.
Yeah, thank you, Colin. I was going to ask for a quick update on what the status and plans are for crowded field photometry and astrometry. And part of that's from the point of view of what input do you need from us, the science collaborations, and on what kind of timescale?
The great thing about asking questions on Slack is that I know when the question is coming, so I think I'll address that a little bit. As of the Algorithms Workshop, we had some prototype implementations that were sort of starting to address the crowded fields problem. And we've been building those out since then. And I think the biggest improvement now is that we actually quantitatively test those initial prototypes against sort of battle-tested state-of-the-art processings of the exact same data. So we're now able to start looking quantitatively at what specific aspects of crowded field pipe processing as a whole are the limiting factors for the pipelines. Because there's like the classical problem of simultaneous solving, but then there's a lot of stuff around it that also needs to get right.
Right, yeah.
So I'd say at the moment we sort of have a good basis for comparison on that. So we sort of, we have a good sense of what sort of the state of the art in that field is at the moment. And sort of as we get closer to matching that progress, then I think we'll be in a better position to sort of open it up to the broader community to get more data sets to test against and sort of definitions of what doing good means in terms of crowded fields. But we're getting.
That sounds very encouraging. So do you, not to put you on the spot, but do you have a sense yet for what kind of timescale you're going to want input from us on that aspect, the data sets, or what we think the state of the art is, or that kind of thing?
Like Jim said, scheduling priorities are always really tough here, so I don't think I can make any concrete statements about that.
Okay, fair enough.
I think there's at least sort of like many months of the testing that we're doing right now already, at the very least, before we're ready to broaden that.
Okay, thank you.
Do we want to address, I'm just catching up on the Slack that I missed while I was speaking, but do we want to address the question of where to go? I guess Tom Wilson asked a question. Sorry.
I did, but I think I got the answer to my question, but if you want me to ask it so you can answer it for posterity, I'm happy to. Where do I go if I want incredibly technical details on these algorithms instead of high-level overviews?
You want to answer your own question now? We told you the answer. You can become very glorious.
No, I'd have to read many of these very technical documents to be able to understand the answer. I asked the question. That made me seem smart.
Okay. So there were various answers you got. One of which was that there's an oldish paper by Jim Bosch on the HSC pipelines, which is a snapshot of the state of the art of the pipelines a while ago, running on real data. So we put in things that might be of interest. Asking questions on community is a good place to start, and those will get triaged down to the experts who should, I hope, in fact will, give you the answers that you need and you have a chance to say. But I wanted to know which line of code it was or whatever, which brings us to the fact that both the source code and the documentation is available from GitHub. So you're welcome to read that. And then there's the DPDD, which is also known as something rather 163. And the URLs to read that, that's the data product definition document, are also on Slack. So there are a variety of places. The one thing that will not work particularly well is to try to ask Jim Bosch or Colin or somebody directly on Slack, because we're trying to make an effort to answer questions in public so everybody can benefit from them. So you may get deflected to get the answer in public, but it'll be the same people answering it.
Yeah, I'd like to strongly second what Robert just said. Please, if you have questions on any of the topics concerning Rubin algorithms, please start up a discussion on community. It's not just the people in the science pipeline team who can help you, but the wider community. And we'd love to start discussions in this forum on the topic of Rubin algorithms.
I just wanted to follow up on Robert's comment on Jim Bosch's HSC paper. That paper is extremely useful. People should really look at it. It should almost be required reading, I think. So it's not so much even understanding the very technical details of how every algorithm works, but it gives you an overview of what everything in the catalogs are and how they're related to each other, which is something that if you don't understand, what the reference bands are and how flow photometry is working and what you're really looking at, is really confusing unless you've read that paper. So it's a very good paper. Everybody should read it. Just wanted to back up Robert on that.
Thanks, Chris. I agree with you.
We have another general question from Nicholas Walton from back at the beginning, but I did not forget about it.
Oh, right. Okay, thanks. Yeah, I was just checking really on what's the status of the end-to-end testing. So Will reminded me about the test plan, but there were quite a few things that are happening basically now in the test plan in terms of operational rehearsals and so forth, which implies that algorithms have to get pinned down soon. So I was just wondering what that sort of process is, especially as the test plan looks a bit vague on what the operational rehearsals are, for instance. So any comments on that? Because, time is getting short, I guess, before real data appears.
Yes, I think your question in Slack was a bit more about data volumes. The operations rehearsals are mainly about operating algorithms and the telescope, starting with more with the algorithms and later with the telescope involved. And we did actually run operations rehearsal too the last few weeks with ComCam in the base, because that's the best we could get for a piece of hardware. The other things you mentioned were EP0, EP0. data we will run with, probably with desk data. There's MOUs outstanding for that to allow us to use that or not. And then as we get to those ops rehearsals, we will write documents defining them a little bit more complete. But I think we're trying to stick with them.
We're losing you, Will.
Instead of using ComCam data to keep us going. Okay, no good.
Yeah,
I sort of lost that.
I think Will said we've just run an OR transferring ComCam data, which is one raft of LSST devices, up to NCSA. And that's an example of one of the things that we are demonstrating. We're moving towards production readiness on. And of course, we're also processing DC2 data and HSC data, which perhaps is the scientific side of the same question. Is that okay, Will?
that sounds good, Robert. So we have a few minutes left. Colin, I think we have a couple more questions that have just come up.
I'm going to give Robert this question from John Gizis.
I was afraid you would, because that's a management question. I'm not a management guy. I don't know what the best place to follow that would be. I can tell you what the plans are, but that's not the question being asked.
Robert, can you just mention what the question was for people who might be watching this?
I'm so sorry. So John asked, we could hear a little bit more about DM's plans of parallaxes and models for faint stars. And the answer was that I could tell you what the plans are, but I don't know where you should follow that. So the plans are that we're currently investigating GBDES and PixMappy, which are the codes developed by Gary Bernstein for DECAM. They don't quite work directly for LSST, well, they do work, but there are some issues because it's the difference between equatorial mount and a non-equatorial mount, an Altaz mount. But we're currently prototyping that code in the DM stack on HSC data. So that's a 5-parameter model. Now, that gets down to the point that a position is pretty much a sufficient statistic on a single band exposure. And then you can just process to get motions and parallaxes. We haven't made detailed plans for what we're going to do down at 26th magnitude, though there are some ideas, certainly to recover the parallaxes at those levels. But the question, where should I follow that? I guess ask the question why you should follow that on community.lsst.org, and someone will come up with a venue.
Maybe one more quick question from Peregrine McGee.
Yeah, hi. Yeah, we're also aware that there's an ongoing crowded field task force through the TVS science collaboration. What, if anything, is the connection and communication between that team and project?
So I'll make just a quick answer on that, is that we're aware of and sort of watching their progress. I think they're kind of coming from a more scientific validation focus, and we're sort of coming at it from a building up the code that fits inside of our pipelines perspective. So I think those are approaching the same point from different directions. So we're watching that. And I think maybe Fred wants to mention what he just said on Slack for any video watchers later.
Sure. Yeah, so what I've been doing is working with Massimo Dall'Ora and some of the other people in the TVS Crowded Field Task Force. And so what they're doing is we're looking at, the NGC 6569 globular cluster. And we're attempting to run that using Scarlet as we continue to modify Scarlet over time to see how, to use this as kind of a baseline for a crowded field that's, not necessarily in the galactic plane. And so they're running kind of Massimo's version of the AOFOT. And then we're, continually comparing results so that we can try to, see how we make progress.
Okay, thank you very much, Fred, and thank you for those questions. We're at the bottom of the hour now. We filled up the hour, so we will conclude the session now. I'd like to thank everyone for attending. We had something like 160 people, I think, join at one point, and we have something like 120 people on the Slack channel. Thank you again to the community for their input questions. Thank you for this lively discussion that we've had during this session. And finally, I'd like to thank once again the whole Rubin Science Pipelines team for the enormous effort they put into the preparation of this workshop, for the preparation of the talks and the data, for the algorithms workshop presentations, and the follow-up answers to these questions. This session has been recorded. The slides have been made available. I saw a comment that somehow the URLs had been dropped from the PDF version. I will get on that straight away. So that concludes this session. Thank you very much, everyone, and I will probably see you at some other sessions during this week.